everyone. My name is Nirit Segal. I'm a developer at AppsFlyer. And this is my family. I have 2 girls, a boy, and an amazing husband. And every day, I'm grateful that they are safe and healthy. And keep reminding myself that the clicker is not working. They gave me the wrong one. I hate that it became a joke because there are so many other families that are still waiting for the safety and security of their family members. So, my name is Nirit. I said that. Today I'm going to talk about integration tests, as written in the title. And this is an integration test that I wrote. Well, actually, this is an integration test. It should upload files to the bucket. And I'm using a local method that I wrote that scans local directory and uploads all the files into remote storage bucket. And this is the SDK that I'm using, AWS Client S3, to upload those files. And basically, what I'm testing is the integration layer between those two. But I'm not really going to talk today about integration tests. We have Yoni for that. I'm also using Node Test Runner, and I'm not going to talk about it either because we have Nitzan for that. And I'm not going to show you my code because this is not a topic, and I'm going to spare it from you. I'm going to talk about integration tests infrastructures. And bottom line, or TDR, is that you must containerize your integration test infrastructure. So if you already do, or you believe me but don't, feel free to move on to the next lecture at Hall A. But if you don't, so what are the infrastructures of my integration test? It's only those 2 lines. I'm preparing my test environment, and then I'm destroying my test environment. And that is the infrastructure. And they are implemented here in a different module called helpers. And this is the model. It exposes 4 properties. The first 2 are related to configuring my integration test environment. I'm having a dedicated test bucket, credentials, region, whatever required. And the methods are preparing the test end by creating a bucket that I can communicate with and deleting that bucket. And again, it's opinionated, negotiable, whether you want to delete your bucket or keep it, whatever. So this is the architecture of my current infrastructures. I get my node process, which is running the test, and then it communicates with a remote test bucket that is running on the cloud provider of my company. And it's great. But then comes other developers, and they also want to run their integration tests. And now we're using the same bucket to do so. And it sucks because I'm going to delete their bucket. They're going to create a bucket for me. I'm going to delete their files. They're going to delete my files. We have race conditions, rate limit. Test becomes flaky, we no longer trust it, we don't maintain it, no integration tests for us. But it can be solved. We can generate random namings and IDs for the files, for the buckets, but that's a lot of work to maintain just for running an integration test, and we developers are quite lazy, so it's not going to live for long as well. And we have no control. Look at that bucket. It's on the cloud provider. Whether it's in a staging development account, still it is maintained by the platform team, the DevOps team. They can suddenly one day decide that they have a new retention policy that deletes the buckets. Security comes and say, oh, no more public bucket for you. You need to submit a ticket to get permissions. And we lose the control over the bucket maintenance. And it's a lot of time waiting for all that overhead of maintenance, not even talking about connection times out in real time, in the CI pipelines. So we drink a lot of coffee, we get nervous, no more integration tests for us. But we can solve it. We can containerize our integration tests infrastructure using Docker. It's 2024. I'm allowed to say Docker and don't have to explain myself. And you should all nod and agree with me that Docker is the right solution. And this is how I do it. So I'm adding additional assignment to my test preparation. I'm starting a Minio container. Not going to talk about why I chose Minio. We can do it later in the question, which will not come because I'm out of time. And that initiation of the container is actually implemented in this Docker command because it's my local Mac. I have Docker agent because it's 2024. And I'm setting all the configuration credentials and whatever is required for my storage, object storage container. And it looks bad, but it's working. However, we can still optimize that. Instead of having a lot of textual commands, we can use Docker Compose, which is today native in Docker, and have all the configuration stored in a very clear, dedicated configuration file. And here is pretty sure, yes, I had it. And here is the configuration file, so I'm telling him use Minio image, I'm using Bitnami, again, we'll explain to those of you who are interested, and configuring the exposed ports and the credentials required for initiating my test bucket. And now, I swear I clicked and it's not moving. I see it here. Okay. So I'm going to stand here. No speaker notes for me. This is my architecture on my local Mac. So I get my node process, and my already installed Docker agent is initiating a test bucket in a container, and I'm good to go. And other developers are coming. It's not because she's bored. She has other tasks. So they come along for the party, and they want to run the integration test themselves. And amazing. Everyone has its own isolated environment, and we're happy. And it's great, because first of all, I get consistency, right? I configured the flow of my integration test, and no matter which developer decides to run that infrastructure or test preparation, we all get the same environment. And I get clarity. If you remember, we also do that in Node environment. We get a specification of all the dependency of our application. And that's great because I just configured the dependency of my test integration with the Docker Compose file. And everything's given. I get full control because I can decide about the node, I can decide about the bucket, yes retention, no retention, credentials, whatever. It's under my control. It's part of my repository. I'm fully aware of the environment that I'm running my code in. And it's faster because it's local. I don't need to initiate a real-time remote connection to some remote cloud provider, etc. Right? So now I'm pausing because I tend not to pause. So what we saw here, and is visible here but not here, yes, thank you, okay. We solved our local development experience, right? I'm running integration tests, set the infrastructure to be optimal whenever they are running on my local machine, which is the Mac. And I get a stable environment. It's trustworthy because I can reproduce the same environment over and over again. It is isolated and it's well documented. And I did not add a GIF because I have enough drawing and it's kind of a sickness I have. I put GIFs everywhere, so not GIF for you. And I'm ready to merge. Ish. Like, let's say that I'm a single developer and this is my private repository at GitHub, or I'm like a part of the founding team of a startup. And bottom line is the rule is that the amount of developers can be counted on both of our hands, not including the fits. That's fine. We are ready to merge. We usually don't add any more steps in the flow of the deployment. And it's cool. And you can, by the way, leave the room if this is your development environment. Shouldn't have added that was hard to say. But if you are half-matured startup that already have tens of developers, you are spread across multiple teams, like 2, 3, maybe even 5 teams. You probably have a DevOps team. It's usually at this amount composed of a single DevOps that is also the team lead and the team developer. And now you're starting to have an automated CI, continuous integration, to be able to manage the guidelines, the flows of the organization for pushing code to production. So let's say that your company is using GitHub. We are using GitLab, and I will not tell you which I prefer. GitLab it is. So let's say your company is using GitHub, and now you have configured the workflow or pipeline for your continuous integration in order to run your integration tests, which are not related to one another. But again, I'm talking about my integration test infrastructure and know how to create deliverable assets. And this is the only line. This is the only line that is relevant for running the integration test, node dash dash. It's not even dash, it's test. And it's running the code that we saw earlier on my repository. It prepares the test environment, which creates a Docker container and destroys the environment. And this is how it looked like when it ran on my machine. So in GitHub, they have a different architecture per each CI provider. In GitHub, they use by default virtual machine. So now my Docker will be initiated on the Ubuntu latest image that will generate a virtual machine. Pause. Why pause? Well, because I used virtual machine and a Docker in the same sentence, and that's no longer fair. We need to clarify some stuff about them. So here a server. We have the hardware and the OS and the kernel that helps it communicate with the hardware. And then if we talk about virtual machine in the new generation, then we usually have a software of hypervisor that is able to generate virtual machine or guest host with their own operating systems and kernel, and above them we have the layer of the application. And this is what GitHub by default spins when it initiates a runner per each job that you configure in the workflow. Now, when we talk about Docker, it looks a little different. We get the hardware and the OS and the kernel, and then we have the application, the container agent. In our case, it's Docker, which initiate containers, and those containers share the same operating system and kernel in order to install, run, manage applications. So we know the difference between those two, and we can go back to the integration test infrastructures and how we automate our CI, and this is the workflow configuration we just saw, and this is how it looks like. So I'm pushing my code to Git or whatever source version control I have. The CI provider, GitHub, GitLab, Circle CI, Jenkins, no, is detecting the event, and then it spins a runner to execute my job, which install and run a node process, and then use the already existing Docker agent in that virtual machine to spin a Docker container with my test bucket. And then the click doesn't work. That's crazy. Okay, it's still not working. Okay, so that's the only step that was relevant to my integration test. All the other steps are simply preparing the environment of that runner and destroying it. And I really hope it would work, but like you see it, now you don't, okay. And remember, this is the size of the organization. So what I showed here, again, okay, never mind. Let's just skip. So it was just one runner. Now it's 40 developers. We get many runners, many jobs, many pipelines, many push. And this is how it actually looks like for that, that size of organization. And okay, all these events are coming, and now the runners are initiated and doing what we ask them to. But then comes that team that says, oh, well, we want to upgrade from Node 16 to Node 18, and now we can no longer use Ubuntu 14, we have to upgrade to Ubuntu 20. Well, that's fine, because upgrading to Ubuntu 20, it's usually out of the box provided by your CI provider. So if early we saw Ubuntu Let's Test, we can specify the required Ubuntu version that we want, and it's fine, our pipeline is still working. But then comes that smart team that really have to mess things up and have special requirements that can no longer be supported by default from your CI provider. And DevOps come to the party, not so much of a party, but okay. And they start to maintain a customized image for that virtual machine, especially for you. And now the clicker doesn't work. I don't know what to do. Oh. So before I had a unified image that everyone used, and now there's another slide. I'm going to move to the, I'm just going to click here and that's it. Okay. So, okay, it moved. Ooh. No. This is not Mac. I don't know what to do now. Okay. Ha. And now this is our fleet of runners. They spin off different images of virtual machines that are maintained by the DevOps team. And remember, it's usually a DevOps team of one, maybe a team lead and one developer, but they do the same work and they don't sleep at night and they work extra hours on weekends just to maintain all those special requirements that we have because we decided to use some software that is not supported by the default operating system. Yes, I clicked, okay. And it sucks, spoiler alert, because first of all, you get the forest. So the forest is from the story of I asked for a banana and then you gave me the monkey and the forest. I asked for node process and object storage container, and instead I got an entire operating system specification for initiating my integration test. Also, I don't know how to work with. Okay, also you get the blame because you start to ask for special things and it generates tasks for other teams. Nobody's happy about it ever. And platform doesn't like you anymore, DevOps. They're still not a platform. And then you become the bottleneck because your requests are being backlogged and your code does not get deployed into production. The product is not happy. And I'm saying all that, but you don't see the slide because it's in the computer, but not on the big screen. Okay, so it was big and now it's small, and let's go for the last one. So no job for you, not the paid job, which probably might happen as well. I'm speaking about the workflow job that executes your integration tests. It's not running and you're sad. So we know how to solve it. Like, can I hold the computer and show them? You can containerize, oh, so it's slower. So I need to talk slower, but I only have 10 minutes. Okay, so you containerize your continuous integration just like when you did on your local computer. So how we containerize and move from virtual machine, which requires, I'm waiting, operating system and kernels and applications. No, it's not showing up. It is? Okay. To a Docker container. Like, oh, and again, it skipped the slide. I don't know what to do about it. Okay, so in GitHub, it's easy. Workflow, you set container, you tell him which image you want to spin the container from, and that is great. And then, I don't know, it's crazy. And then this is how my running environment looks like. So I get a node process running inside a container. But I still need Docker in order to run my code that initiates a Docker container for the object storage. Long sentence, short solution. I'm going to use service containers, which is basically it's a functionality that all of the CI providers opens for us. It allows us to spin service dependencies as containers, Docker, whatever, as part of our job. Should I click it and see what happened? Wow. First click. Now I'm going to talk super fast because there's no time. Okay, so this is what I'm doing first. I'm spinning a Docker agent because it was not exist inside my node image that I started to use. And this, it's going to act as the service of Docker for my code to run Docker containers. So now I have Docker available for my node process to spin. But still I'm missing the way to communicate with it because, again, my node image is not aware of that Docker. So I'm installing Docker client or Docker CLI to be able to run the command we saw earlier that starts a Docker container. It looks bad, but still it is great because now we can see that the clicker stopped working again. And you get the banana, just trust me, it's written there. Okay, so before we had to maintain an entire operating system that matches our dependencies, but now I can be satisfied with service or application dedicated configuration. So I'm saying which node I need and which object storage I need, and I'm good to go, and I don't need a platform team for that. And then I call it house board, like in the hotel, because now that Docker service is actually maintained by the CI provider because now it is aware of it because I added it to the configuration of the workflow. So it knows that when the job is finishing to execute the code, then it can terminate that service, and that's nice. And I get full control because I can select all the versioning and dependencies that I have for that integration flow. And I can keep my job for now because it's running and I don't need any other support from other teams in order for it to run. And it's great. But now we move on to enterprises and big companies that counts hundreds of developers. And when we come to that size of organization, then time is money, and we really need to optimize everything. And money is money. We don't want to waste machines and CPUs. And the complexity of the microservice ecosystem increases because now they want my service to work very fast, so I will probably have to add some Elasticache or cache storage to give faster answers, and they will no longer allow me to store my credentials locally on the repository, so we will probably use Vault or some secret manager in order to manage the authentication of the services. So we know how to fix that because we already met service containers. And now, instead of installing and using Docker service, I'm using the actual service that I wanted in the first place, which is Minio, that is API compliant with AWS S3, which is the object storage provider that we work with. Click. Yes, this is how it looks like. Very simple, very similar to Docker Compose configuration file. I get the image, credentials, ports, and I'm good to go. And now this is how the architecture of my pipeline looks. And it's great because I get the banana. I only asked for Node, and I only asked for storage container, and I got them, so I'm happy. And I get full board because now the CI provider is fully aware of all my dependencies for that job and is fully responsible for monitoring them, initiating them, destroying them, and report any issues that comes along the way very clearly. And I get the full control because, again, I select images, I configure them, how they behave. I don't need anyone for that. And my job is running again and again and again and again, and I'm happy. Pause. Why pause? Well, because I said at the beginning that you must containerize your integration tests. And now all of you know why you should do that. And we are only left with one last assignment. So if you remember, I configured my image, but it was configured both on my Docker Compose that is running locally and on my workflow configuration file. I also configured the port and the credentials. Maybe it will show that, maybe not. Let's click and see what happened. No, it doesn't. Well, that's okay. You can trust me, credentials. So we want to unify that because it's not good to maintain code or configuration in different files. It doesn't matter if we're even only 10 developers, the other developer will come and say, oh, I want to change the image. Here is a single place that I found it. He will change it, but he won't ever change it in the other place. And things start to get flaky. You don't maintain, no integration test. Bad. So we want a single place to maintain all those configurations and consume them from it. And I used in this example a .env file. There's many alternatives for that. But here I'm holding all the credentials, the image, and whatever is needed for the configurations, and I can consume it. When talking about the Docker Compose, since it is initiated by my node process, then once the environment variables are available in the system, it can use them when it parses the configuration file. But when we talk about the CI provider and the workflow configuration, it's a different issue. Because the CI wants to optimize the behavior of the jobs and provide an entirely isolated system, environment or system per each job. So sharing auto-generate or runtime-generated environment variables is not possible. But all those CI providers do offer a solution for that. Some call them artifacts, others call it output. Eventually, it's a file with data that can be shared on the descending jobs and stages as static assets. And here, you can see how I create it in GitHub. It's implementation details, so I don't really like that I'm showing it to you because it's differently implemented in every CI provider. But here I'm exporting my .env file into GitHub env environment variable, which is actually a file that holds all the configuration of the environment. And the clicker didn't work, but above it you can see how I consume them. Worked. As outputs. Properties of that job, and once that job is configured as a dependency of my actual integration job, then I can use those properties when configuring my service container for that S3 storage service. Oh, I get it bigger. Nice. So you can see it. Still. If you've never used it, Google it. Implementation detail, clicker work. So let's do a recap. Yeah, that worked. Now, this was in my abstract. I said that once we finish that talk, then all of you can say something regarding scalable and maintainable. So now we have a scalable integration test environment, and it is also maintainable because all the configuration lives in a single place, and people can contribute and change as the product evolves. And we're done with integration test infrastructure. You must containerize your integration test, and size do matter. It changes over time according to the size of your organization. I do, key takeaway, recommend you stop harassing your DevOps teams. It never ends in a positive way. And strive for self-control and clarity of your architecture. And please keep it simple. Thank you. No time for questions.